Okay, so this is the first of a multi-part video I'm going to do talking about fan-like characteristics. So let's consider that we've got Burger's equation, this thing here, the inviscid Burger's equation. We can go through our usual method of characteristics solution. So I've already written that out here. You make this hypothesis. X is a function of time. This gives you some characteristic curves in space. This is the chain rule. We write out the chain rule to find the total change in, say, density rho with respect to time. It has this form. And if dx dt equals rho, then we can, by comparing these two equations, we can write down the following ODEs. Dx dt equals rho, which is sort of, if this is true, then this one's true. And dp d rho dt equals 0. Now, immediately, if d rho dt is 0 on the characteristics, that means rho is constant on the characteristics. That means that on the characteristics, the density must be equal to the initial condition. Right? That's what this line here says. Now, because this equation here defines characteristics, what we can do is we can just plug in rho naught, which is something that we know, because it's constant on the characteristics. We can then integrate that with respect to time. Because x, it's x of naught. We can integrate that with respect to time and obtain this linear equation, which is the characteristics. So the characteristics of straight lines. It depends on the initial value of rho. Right. So I've got two different initial values of rho here. They're step functions. This one here is just a, if we sketch it out, rho x 0, then it jumps, and then it's 1. Okay, so that's the first case, I guess. And the second case is very similar. It's just that the jump's in a different spot. Right, so these are nearly identical initial conditions in some sense. You know, so that's 2, that's 3. So they both have the same characteristic, that it's low density going into high density, if you like. The higher density is always on the right. In the next video, we'll use the information that we've got here to sketch the characteristics and discover fan-like characteristics around the origin.